Okay, right now we're looking at a class named pair. There's one member variable named values, and if you notice, that variable is a pointer to an int. The intent here is that this class stores two values. Okay, so you might wonder why I don't just declare two int variables here and use those as the member variables of the class. And I definitely could do that, but this is a demonstration of using dynamic arrays and the things that can happen when you use dynamic arrays or pointer variables, pointers in general, inside of a class. So values is going to be a dynamic array that can store two values. Okay, so since it's going to be a dynamic array, it's declared as a pointer to an int. Okay, and then it will have your basic functions. I'll have three constructors. I'll have a constructor that initializes both values in the object to some default value. Have a constructor that initializes both values in the object to some int value, and a constructor that accepts two parameters for initialization. And I'll have get functions for both of the values. Okay, have set functions for both of the values, and have some operator overloads. This particular class, for convenience, also has an overload for the output operator. That can, of course, can never be a class member, and it's not. But I do actually have the prototype for it declared here. So when I include pair.h or ppair.h this file in a main that's going to use it, the prototype is provided. Okay, so let's just look at the CPP file, and in particular, let's look at the constructors. Now, if you remember, the variable values was declared to be a pointer to an int because the intent was that it be a dynamic array. Okay, a dynamic array needs to be created at runtime. So if this particular constructor is called, my dynamic array is created and assigned to values, and the two numbers stored are 0 and 1. If this particular constructor is called, my dynamic array is assigned a new, my variable value is assigned a new address of a dynamic array that's created, and A is stored in both elements. And if this constructor is called, yet again, a dynamic array is created and assigned to values, and the two parameter values are used to initialize that array. Okay, so that's pretty much, as you remember, the big difference, the big deal with a dynamic array is the creation of it and when you create it, and you kind of have to remember it happens at runtime. So my gets will be the same as they would have been. Values is an array. Get val1 is returning the first element. Get val2 is returning the second element. Nothing different than if it had been a fixed size array there. And the same thing with my sets. Set val1 sets the first element of the array. Set val2 sets the second element of the array. And then there's overloads as you would expect. And again, and then here the definition of the non-member function is included in this file, so that again both the H and CPP file for this class can travel and be used with different main programs, and the capability of outputting an object of this type will be provided automatically through the inclusion of this function. Okay, so let's look at something interesting now. So we have this class called pair. Okay, and I had three constructors. One that took two parameters. Okay, so if I output this object, and the two values stored in this object were printed, it would print 6 and 7. Okay, and if I created another constructor, another one. Another object. I could also print out that object. Oh, sorry. C++, when you're creating the, when you're using the default constructor on an object, you don't put the parentheses. Sorry, that was my forgetfulness there. Okay, and then I could do the same thing with the other constructor. So cool, I can see the two objects. Now, there's also another type of constructor that if I don't define, C++ will provide. It's called a copy constructor. So let's suppose I say pair 3 equals 2. I'm actually asking C++ to make 3 be a copy of 2. When I do something like this, when I'm creating a new object to be a copy of another one, C++ calls a copy constructor. And right now, the copy constructor is something that will be provided by C++ because I have nothing special in my class to handle this situation. I could also call my copy constructor this way. Okay, and again, this is saying create the object 4 to be a copy of number 2. Now again, I don't have a constructor that takes a object of type pair, but C++ will recognize that this is a copy constructor. A copy is being made, and it will provide a copy constructor. Okay, this happens with any kind of object. I happen to be doing this with pair, but I can do these kind of things with any class object that I want. But it gets interesting when my class has a pointer as one of its member variables. So here I'm doing two things that would be totally normal and be totally wonderful in many situations, but there's going to be something to look at here with my class pair. So 3 should be a copy of 2. 4 should be a copy of 2. So let's also print out, let's verify this by printing out 3 and printing out 4. Okay, so here's object 1, object 2, then yes, object 3 and 4 certainly look like copies of 2. They contain the same 2 values. Now I'm gonna do one little thing. Let's see. I need to change the value 1 of object 2 to 55. So I'm going to call setVal with 55, and that particular call will cause this set function to execute, and the set function changes the first value in my array. Okay, so the first value that's stored has been changed in object 2. Now, just for the heck of it, I'm going to print all 4 of these out again. Now, this is kind of interesting. So this is 1, 2, 3, 4, 1, 2, which I just changed, and there's the reflection of my change. But oh, when I changed 2, my goodness, I also changed the contents of object 3, and I also changed the contents of object 4. Okay, there's a reason for this. The reason for this is that the C++ copy constructor doesn't behave in the way we would want it to behave when our variable is a pointer. In other words, when I did these kind of things to make copies, I thought the copies would be independent, totally independent objects, totally non-associated, such that when I changed 2, it would not change 3 or 4. Okay, but let's look at how the C++ copy constructor, which is what was actually being executed here to create these objects, how this constructor behaves. To do that, I'm going to actually start. I'm going to write some code. I'm going to actually start the definition of my own copy constructor. If I was writing a copy constructor in C++, a copy constructor is a constructor that takes a parameter of the same type, because it's creating an object and making a copy of this object. And of course, since this particular parameter is an object, I want to pass it by reference to make it fast, make it a const so it won't change. Okay, that's how. So this is a copy constructor. Okay, so there's my prototype in the definition. I'm sorry, in the class declaration. Sorry. Now let's see. I'm gonna put the same thing down here. Okay. Now, pair. Pair is a parameter. OBJ is a parameter of type pair. Okay. And again, it's being passed by reference, but to be fast, but I don't want it to change. Now, the way that the C++ copy constructor behaves, which works for any class that does not have any member variables that are pointers, is it just makes a copy in every member variable of the identical member variable in the object to be copied. So here, values is the variable in the new object, and what am I initializing it with? I'm initializing with obj.values. Now, that seems reasonable, except when you remember that obj.values is a pointer. It's not an array. I'm not making a copy of an array or anything like that. I'm making a copy of this value. What is stored in this value? Not an int, not 2 int values, not anything like that, but a memory location. It's a pointer. So it's the memory location of an array. So when I make a copy, or when I assign what's in values, the values member variable of one object to another, I'm copying the address that's in here. Okay, so here, when I say obj.values, I'm taking the memory address that's stored in here and storing it in the values variable of the new object. So what I've just done is make the new object point to the array that's in the second object. Okay? And that's not what I want to do, because then now my new object is sharing a dynamic array, sharing an array with the object it's supposed to be copying. And what I really wanted was independent copies. So this is what the C++ copy constructor would do, because it just makes a copy of every single member variable into the new object. And it unfortunately, I have a pointer here, so this is not going to work. What I want values in my new object to be is not a copy, not the same as the values in the object here. I want it to be a new int array, because I'm creating a new object. I want it to be independent. So now I have a new dynamic array. Now, what do I want to be stored in that new array? I want values at index 0 to be equal to obj.values at index 0. because I was making a copy, so my new object should contain the same values. And I want values at index 1 to be initialized obj.values at index 1. Okay. And so that's great because, well, now my new object has its own independent array, but it's going to look, this object's going to look just like the other one because that new array contains copies of the ints that were in the other object. Okay. So in other words, I've created a copy constructor, but mine works correctly. Now, when I write a constructor with a signature like this, okay, my copy constructor will be used instead of the copy constructor provided by C++. And C++ will know it's a copy constructor because, well, the name of the method's pair, and the parameter type is a pair, but it's a const by reference. Okay, so let's go back and let's go back and run the same program again. And now if we look, we see, yeah, when I changed, all these three guys were identical, but when I changed object 2, object 3 and 4 did not change because the objects 3 and 4 no longer share arrays with object 2. Okay? So the point here is that when you have a variable that's a pointer inside of a class, you need to write your own copy constructor, and you need to make sure that you allocate new memory for those pointer variables. Otherwise, a straight copy would just cause two variables to be sharing the same memory.